Hope everyone can access Notion. Not everyone. Okay. All right. So what we'll just do for today is we'll still drop the link on WhatsApp so that everyone can still access it. Then it can be whatever issue Notion has, it can be sorted out today, and tomorrow we'll continue. Yeah. So on our Notion board, we can move on to curriculum. And since we are still going to talk about the practical for yesterday, you can open up the training section on training one, and then yeah, wait for it to load up. Under resources, which is down, you're going to see three links. We have metamax.io, we have faucet.com/arbitrum, and then we have sepolia.abiscan.io. We have handled metamax.io. What we are going to be doing right now is faucet.com/arbitrum. So I will just copy this and send it to the WhatsApp group. Okay. So I just dropped the link on the WhatsApp group for those that don't have access to Notion. Then I can open this up. Okay, new tab. Please, those of us online, hope you can see my screen. Can you see my screen? You can hear me? Okay, please, can we all hear me? Those of us online, can you hear what I'm saying? Please, if you can hear me, just signify.
Yes, we can.
Oh, okay then.
Yes, we can hear you.
All right, thank you. And can you also see my screen?
Yes, we can see your screen.
All right, thank you. Okay, so I'm just going to give us a minute or two to open up this, and then we're going to move on from here. So I'm sure some of us will still be setting up. So I'll just give a minute or two to every one of us. Okay, so I believe at this point we should have opened this particular URL. So for those of us that are just joining us, you can get this link from the Notion board or from the WhatsApp platform. Just open it up. What we are trying to do is we're trying to get the test token, so that can be added to our wallet, which we created yesterday. Now, the steps to get the tokens are quite straightforward and simple. All you just need to do is you just need to fill in this input field. Yeah, so you just click on this drop down, which is select tokens, you click on it, and then you can select this 0.1 ETH, and then once you're done, you can confirm the selection. Now, once you're done confirming the selection, you're going to see it's highlighted here, where you have 0.1 ETH in the drop down. Now, once you're done with it, the next step is you're going to open up your MetaMask. So I'll just switch to account 2. So you open up your MetaMask. Okay, I don't see any. Okay, so I said we're going to open up our MetaMask, and then the address that is located on the top, you would copy that to the clipboard, and then you paste it into this impute field. And once you do that, you would click on get tokens. And yeah, so you can just bypass this. I think this is my. Now, it will take you to a new screen where you can attest and get my tokens. So you can just click on attest and get my tokens. Once you do that, what I say?
So when I click on get what does it ask?
Yeah, so for those of us using Google Chrome, it's going to ask you to create a passkey. So you can just go ahead to create it. Yeah, that was, he asked me for the same thing too, so accept. So please note for those of us using Google Chrome. So once you are done with that, you could, yeah, it will tell you attestation complete and your token is on the way. So you will just give it a certain time. It could be 1 minute, it could be 2 minutes, and then you open up your MetaMask. You're going to see it's been added here, 0.1 septillion RRB. Please, if anyone is stuck, or yeah, if anyone is stuck, you can just drop a message on the chat. Yeah? Please let's make sure our MetaMask is installed on the browser we are using also. So we can all have the issue. User, have you requested before? Yeah, you have to set up your security key or passkey. What browser is it? Chrome. Interesting. I don't know how to. The secret setup is. You can cancel it. Just okay. You're creating a new passkey instead. You can just use your phone. Where is it going to be? Try it again and use your red instead of using. So, all right. To those of us online, do we have any issue? So for those of us that Chrome is asking us to provide our pass key, so you can sign in using your phone. So whatever device you are using, you can just use that to sign in. And I think that should get you past the security. Like those are some people are having issues with the pass key. It's not working for you. Are you?
So if I click this, it will bring out the notification to verify. I'll click on it, but it's not.
It's not coming up.
um,
Interesting.
Maybe I should.
Mm. So if your token is on the way, just wait for a bit and then check your MetaMask afterwards. You will see your balance updated. So for Elijah that is just joining, a link was sent to the group, right? Or you can check Notion, the training one part of Notion, and you can get your facet from there. So we're trying to get the test token.
Hello Ray, you said I should just refresh the page and check if
You don't need to refresh the page, just check your MetaMask. The extension, just check it. You're supposed to see the updated balance.
okay, I'm seeing 0.1 ETH now.
Yeah, that's correct. That's what you're supposed to see. User rejected, it means the passkey didn't go through. What's like in general? So for those of us having issues with the passkey, I think you can create a new passkey, but it will require your phone. So we can try and do that if that should work. That will work. See, you can try to create a new passkey. I think the options below your phone, there's like a create new passkey something. Yeah, I think I can try that. It's working. So you have to attest and get my tokens first. So you have to sign with your phone.
No, 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 you're not supposed to.
I think you can try. We can try Brave browser. Just that you need to install the MetaMask extension. afresh. Please note when you are claiming the token um, after you click on the Get My Tokens button, you still need to attest. So you're going to see a button where it tells you to attest to get your tokens. So you need to still click that before you will actually know that you're done. So for you to know that you're done, this button, you're going to see this, your token is on the way. So it's at this point you know that you are done, and then you can now wait for your wallet. So please let's ensure that you attest first, and then you get this success message that your token is on the way. All right, please. So for those of us that are done, can we just drop done via the chat so that we'll know? Okay, Office, I think you should please confirm that you sent it to the right wallet address, and also just close your MetaMask and open it again. If probably that will load up your balance and ensure, yeah. And please ensure that you have switched to Arbitrum Sepolia from your MetaMask. I think I showed us how to do that yesterday. Okay, so far we have 2 done messages. Yeah, so I think I need like 50% of us to be done before we can move on. Or about 20. So those of us that are here physically, are we okay? You're still having issues. Did you have,
Okay, yesterday I
okay.
actually changed this to ETH to
Okay.
remove the caution, but then
Yeah.
I think relevant.
No, that's very relevant. Just you're still getting user rejected. That's interesting.
Like, bringing the notification here.
Okay. I'm trying to think. Maybe Wi-Fi. Like,
Wi-Fi.
I'm not sure. I'm thinking again. And it just keeps rolling like this.
It will now stop here.
That's interesting. Do you have another browser? Can you connect them to the same network? Probably that would try. Did you try creating a new passkey?
Yes,
What did you say?
it's not scanning. Try to scan it. It's giving me something.
Okay. Bro, are you able to scan your? Okay. I think I tried to use Bluetooth. Okay, Mark does not have Bluetooth. Just try it, Mark. I'm not sure Mark will allow you.
How do you use that?
So, like, try to create a new passkey. Then I think there's an option to use Bluetooth. So that way you can now. Yes. Okay, sorry, I'm trying to people physically to ask some issues. Okay, Abdulhafiz is done. So at this point, I think we have about 5 done. So I'll just give us next to 10:26 so that we can move on to the next thing. Do you have another browser?
Yes.
Okay. Probably can just move. If you have the just quickly set up the you can't add extension to Safari. That's going to take time though. Please, for those of us still having issues with our passkey, probably you can just set up Brave and then you can just go through the steps to see because Brave doesn't have this passkey verification. All right. So we just have 2 more minutes to be done with this setup. So for those of us still battling with it, we're giving you 2 minutes to just move around it. If you still have issues with it, you can drop a message on the group. Okay, so moving on, most of us are done with the setup. So I would just recommend that those of us still having issues, we can pay attention and probably after the meeting we can still try it out with a different browser, in particular Brave, so you can just get this. Now to show this, we have gotten our test token. And with this, you can make transactions, you can use it to pay for gas. All right, please, just a moment. All right. So moving on. Please, the okay, no, there's no need. If you want to transact between accounts, you want to send your ETH to someone, all you just have to do is you can just click on send. So there's a send button on MetaMask. So you click on send, and then you get the options of your account. So every account that you have. So for example, if you created a new account from here, I think I showed us how to create multiple accounts on the MetaMask wallet yesterday. So you can click on add a new account, account 3, and then create. Now, if I want to send from account 2 to account 3, I can click on send and then just choose the particular account. I'll go with account 3. And then from here, so you can type in the value in terms of ETH, or you can click on this icon and then send in the value in terms of your fiat, in terms of USD. So if I want to send probably $100 worth of ETH, I can do this. Or if I want to send in probably ETH, yeah, you can just interswitch the change, yeah, between them. And then you're going to see your gas fee, and it's going to give you how much it's going to cost for the gas fee, and then the timeline. And once you are done, you can now click next. So it's going to ask you to confirm. Now you can edit your gas fee. Above this gas section, you would see market with an icon. You can click on it. There's the low, there's the market, there's the aggressive. Now the aggressive, it will cost you more, but it will be faster. Low, it will delay than the average time, but the gas fee will be less. So the more you pay, the faster your transaction would process. So, and then once you're done, you can click on confirm. You'd wait for it. It takes up time, and then you see it's confirmed. I can switch to account 3, and when I come in, I will see the $100 worth of ETH I just sent. So, do you have any question about what we just did right now? So, I'll just give us the next 3 minutes to replicate what we just did. So, the next 3 minutes for us to just replicate it. So, if you have any question, any hindrance, any obstacle, please just throw the question to the group, or those of us physically, you can just ask it.
My concern is, how do you have ETH when we have Sepolia ETH and you have ETH?
I didn't get you.
I have Sepolia ETH, but you're having pure ETH like the actual Ethereum. How is that? How was that done?
Okay, yeah. So those of us that used secular this thing as a name, please let's update it to ETH. If you notice, it was throwing an error. So the recommended name was ETH. So please let's just switch it to ETH in order to avoid the error. I don't know, those of us that used another name. That is, I mean, from your network settings. Right. Yeah, the currency symbol in particular. I mean, some of us used another name, but then you see that it throws this error. So please let's just update that to ETH. That should- Okay, moving on. I trust by now it should be done. Moving funds around MetaMask, and we should have a basic knowledge of how to do that. Now, what I would want us to do is the Explorer we checked yesterday. I would want us to go there and view our transactions so that we can understand how to view our transactions on the Explorer. So in particular, we're going to be making use of this, the third link on the resource. So under the resources, we just finished with the faucet link. We're going to move on to the sepolia.abiscan.io. So I will drop this on the group. And those of us on Notion, we can find it from training one. Okay, now to view your transaction in this search bar, you can search by address, transaction hash, the block or token. So what you do is you come here, copy your address. So you open up your MetaMask and copy the address, and then you can paste it in this search field, and then you click on search. Now it's going to show you under transactions, you're going to see a table with different details. Under overview, you'll see the balance of 0.1 ETH. And then under transactions, you would see an entry. Now, what this entry does, or what it's trying to show you is the transaction that actually took place on this address. So you can see the address it came from. You can see the address it entered. You can see the block, the method, the transaction hash, the age, when was it done, the value, and then the transaction fee. Now, so I think my account still has like two transactions. So I'll just come here and copy this. Yeah, so you can see here that I did two transactions. It's reflecting here. You have the first entry, which is an out entry. You have, yeah, the one on top is the out entry, and then the one at the bottom is the in entry. So you can see the value, transaction, basically everything you need to know about how the transaction went. You can all view it via this Explorer. Each network has its own Explorer. So depending on the network and tokens you're dealing with, you can view them depending on the Explorer. All you just have to do is search into it and then you'll get that. So at this point, Please, if you have any questions so far, you can just drop it because we are going to be moving on to today's class. All this, what we've been doing was meant for yesterday. So we're moving on to today's class. But we need to move on as quick as possible. Any question by 10:40, we're moving on to the next agenda. So we have 2 minutes to throw in any questions or to be done with our tests. Yeah, Paul, I think you can go ahead to drop your question on the group, on the chat, sorry. All right then. So we're going to moving on to okay. So we'll be moving on to today's class, which we're going to be talking about cryptography, cryptography and peer-to-peer networks. As you know, my name is Akingre. Yesterday we talked briefly about cryptography, and I think I mentioned the definition, what cryptography meant. So we're going to be looking into an in-depth understanding of cryptography and how cryptography works, what is its purpose, and we'll also be looking at peer-to-peer networks. Please, the resources for this class is on Notion. So for under 22, just check the training info and you will see the resources for this class. Every link we're going to be using is going to be available from Notion. Thank you. Now, the objective of this class is we're going to understand the fundamentals of cryptography, peer-to-peer networks, IPFS, the role of consensus algorithms in blockchain technology. We are going to be understanding these particular 4 objectives. What is cryptography? Cryptography is the science and practice of secure communication in the presence of third parties. It involves converting plain text into ciphertext, yeah, and vice versa, using various algorithms and mathematical concepts. The whole idea, basic understanding of cryptography is that it is used in communication. So, for example, if I'm trying to communicate with someone, currently I'm using English, and almost everybody here can understand what I'm trying to say. But in certain terms, there are certain scenarios where you might want to communicate to, let's say, your family member, and you don't want anyone else to know what you're saying. At that point, you turn to your native language, especially if you know the third person there doesn't understand your language. And with that, you have a form of secure communication. So likewise, in blockchain, we use cryptography in communication. So once nodes are trying, yesterday I mentioned nodes are participants, yeah, on the blockchain. So once nodes are trying to communicate with each other, those communications are secured using cryptography. It is a science and then it is a practice. So what it does is it converts plain text. What do you mean by plain text? Your normal words, your normal text into ciphertext. Ciphertext looks like jargons. So a graphical representation is this. You have hello world. Using cryptography, you're going to get a ciphertext that looks like this. So as simple as hello world means, it's going to look like this. Anybody that looks at this won't be able to understand what this actually means. So cryptography involves encoding and decoding. What do you mean by encoding? Encoding is converting it into ciphertext, and then decoding means converting that ciphertext back to plain text. But that is done by the sender and the receiver. So we're going to still look deeply into it. Now we have types of cryptography. There's the symmetric cryptography and then asymmetric cryptography. What does symmetric cryptography does? It utilizes a single key for both encryption and decryption. Examples include DES, Data Encryption Standard, AES, Advanced Encryption Standard. Now, what I want us to understand about symmetric cryptography is that one key is used, that is the private, is called a private key or encryption key. They're actually different, people use different terms for it. But what you need to understand is a single key is used by both the sender and the receiver. The sender who does the encryption, and then the receiver who does the decryption. A single key is used by them. Now, what do I mean? Both keys is going to be agreed by both parties. Like the key is going to be agreed by both parties. That is to say, a real world scenario example is this. If I'm trying to communicate with somebody in the midst of thousands of people or hundreds of people, and I'm trying to communicate with my friend, I can say, okay, John, if I say the word hello, then it means I'm trying to say run. Now, in the midst of people, that particular term hello might mean actually just hello. But then me and the receiver, me and John, we actually understand what that means. And then using that particular term, I can now decrypt and encrypt what what I'm trying to pass at that particular point. Now that's symmetric cryptography. Asymmetric cryptography, it involves a pair of keys, a public key for encryption and a private key for decryption. Now we're going to show some demo for how symmetric and asymmetric cryptography works. Now for asymmetric, for symmetric we said it involves one key for both the sender and the receiver. But for asymmetric, it involves a pair of key. A pair means two. One is going to be the public key. The public key can be accessible to anyone. But then the second is going to be the private key. Private key is just the receiver that would hold on to the private key. Then we have examples such as RSA, ECC. Now, I want you to understand for symmetric cryptography, the security depends on the key. What do I mean by it depends on the key? Anybody that has access to the key automatically has access to the information you're trying to pass. So the security for symmetric in particular is that you need to protect your key. Both the sender and the receivers have to protect the key. Once it's been given to other people or once other people have access to it, then that form of communication is not as secure as it's meant to be. Do we get that? So now we are going to move on to our Notion board and then we're going to open up the first link. So I'll send this to I'll send it to the group. So we're going to be making use of two links actually. I will send the two to the WhatsApp group. So we're going to be making use of the AES encryption.net and then Java in use/RSA generator. Now remember, I said example of symmetrical involves is AES. So we're going to just make use of that briefly to show symmetrical encryption. Symmetrical encryption. Now, notice from the UI, we have where you have the first input, which is the plain or encrypted text. And then we have key of the encryption. And we have 1, 2, 8, well, then we have the bits. So for symmetrical, it could be either 128 bits, 192 bits, or 256 bits. I don't think we really need to pay deep attention into that. Now, the first step is this. You're going to input your plain text into the AES encryption. So for example, I can write just a random word, probably secret key, and then the key of the encryption. Now, for this particular site, there's a particular key. This is just like a demo. So they provided a key, the key which is P at SS, so pass, but then the A is at. Sorry, there's no A again. So just like this. And then you can now encrypt. Please, underneath you see the result of encryption in base 64. And then you see this ciphertext. This ciphertext now, you can hold on to it and share it around. Now I'm just going to copy this and then I'll pass this back into this text. So, and then I will decrypt it. Since this is our encrypted text, this is our encrypted text. So to decrypt it, I'll just click on the decrypt. And then what do I get as a result? Secret key. Do we understand? I was looking like jargon to us. Okay, so notice in this type of encryption, we made use of just one key, which is this pass. And then with the pass, we're able to encrypt and decrypt the text. That's symmetric cryptography. Now, moving on to asymmetric cryptography, we'll be making use of, I said we'll be making use of Java in use.RSA generator. So RSA is a type of asymmetric cryptography. It's an algorithm. Yeah. You take a look at it, you can also see the full meaning: reverse, shaman, and man. Now, this particular generator has 3 sections. You have the first section, which you can use to generate the keys. You have the second section, which is used for the encryption. And then you have the third section, which is used for the decryption. Now, the first step you would need to do at this point is you would need to generate the keys first. So you're going to generate both the public key and then the private key. The public key, just like I've said, is going to be used for encryption. Then the private key is going to be used for decryption at this particular point. So you can copy out the public key, which is going to be used for the encryption. And in here, I'm just going to write in a random text, probably cryptography class. You will input in your private key, your public key, I mean, sorry. And then key type, you specify whether it's public or private. And then the cipher type, RSA, and the rest. But we'll be making use of RSA. And then you encrypt after you're done. It's going to give you this text, just like how it did on the previous site that we checked. So you can copy this. This is going to be your encrypted text, cipher text. If you want to decrypt it, you just come down to the decryption section and then you paste the encrypted text. So this time around, you're going to pass in the private key. But okay, let's try to pass in the public key to see if it's going to give us a result. So I'm going to pass in the public key instead of the private to just show you that it won't work. So I'm going to change the key type to public key and then to decrypt. You would actually see that you get a decryption error. Why? Because you need the private key to decrypt this text. And I'll just copy the private key and paste here. So I have to change the key type to private. And then you get your result of cryptography class. So that's the basic knowledge of symmetric and asymmetric cryptography. Please, do you have any question on those two types of cryptography? Okay, this is just a graphical representation. You can see private key A, first member, second member, they all require the same private key and public key, A. But then asymmetric, it requires different keys. Um, so we're going to be looking at the importance of cryptography. There are numerous importance, but we'll take a look at just three of them. So the first one is it ensures that information remains private and accessible only to the authorized parties. How do we ensure that there are just authorized parties? By making use of the key. So we have seen graphical representation and understand that we need the key for a party to show that it's authorized to view that particular information. And as such, the information remains private. We also need to understand the integrity. So cryptography prevents data from being altered or tampered with during transmission or storage. Now, if you take a look at that encrypted text, the ciphertext, we notice that we can't alter the information passed already. Once you have passed in that particular information, we passed in the text of cryptography class, and then it returned it. Now, once you have that encrypted text, you can't alter it, you can't change it. So that's the integrity of cryptography. And lastly, we have authentication. It verifies the identity of users and ensures the legitimacy of communication. So it makes sure that the communication is legal, and it also verifies the identity of users. Since it knows that, okay, the receiver owns the private key and the sender owns probably the public key or so. So that way it can identify who owns each of, like, who owns the particular key and identify the users using those such keys. So that's it for cryptography. And that's how communication is secured in cryptography, in blockchain, sorry. Now, moving on, we also said we're going to talk about peer-to-peer networks. Peer-to-peer networks. So peer-to-peer networks are decentralized networks where each participant peer. Now, in the network, each participant is a peer, and each peer has his own equal privileges and can act as both a client and a server, enabling direct sharing of resources among peers without the need for a central server. Now, we understand that blockchain doesn't require a central server. Why? Because it is decentralized. What are decentralized? The fact that there's no central authority. It is governed by, it is among peers, like among different participants. Now, to understand client server, this is like the traditional client server relationship where at the center is the server and then you keep serving the clients. You have clients, whatever you need, you go to the server responds to you with whatever request you made. So this is like the traditional client server network. And this is how peer-to-peer works. You can see they keep relating with each other. There's no central authority. They just keep rotating whatever you need. You ask like the node if he has, what does he have? So that's how peer-to-peer network work. And yeah, the characteristics of peer-to-peer is the fact that it's scalable, it's decentralized, and then we have the resilience. Now we have types of peer-to-peer network. There's the structured peer-to-peer network, and then there's the unstructured peer-to-peer networks. For structured it means it is organized in a structured way. So structured networks with a defined overlay topology. We have distributed hash tables for efficient resource location. So it is organized in a certain way where it is easy to retrieve and locate like resources, probably files, since the database is like distributed. So with the structured peer-to-peer networks, it is actually structured. Now we have unstructured peer-to-peer networks, networks without a specific topology, where peers rely on local information for resource discovery. I think we'll still take a deeper look into that. But yeah. So do we have any question on peer-to-peer network? Okay, so no questions so far. Now, please, I would want us to understand that in structured peer-to-peer networks, nodes are assigned specific rules and responsibilities within the networks. So different participants have different roles and different responsibilities within the network. So that's for structured peer-to-peer networks. And then for unstructured, the nodes are connected to each other without like a predefined or order or hierarchy. So they're just connected to each other. There's no structure in place, just like the term itself sounds. So example where you would see unstructured peer-to-peer networks is sharing, file sharing and messaging. So that's where you see unstructured peer-to-peer networks. And then for structured, you're going to see that in IPFS, which we'll still take a look at later on in the class. Now, functionality of peer-to-peer networks. One is resource sharing. With peer-to-peer network, it is easier to share resources. Resources could be your files stored on the database. It could be, it's just resource in general. And then we have content distribution. That is how these contents are stored and how they are searched and retrieved. And then we also have collaboration. Now that's it for peer-to-peer network. Now we'll be looking at consensus algorithm. Now, consensus algorithms are protocols that facilitate agreement among nodes in a distributed network to achieve a consistent system state without a central authority. Now, to understand this, in a place where you have a central authority or entity, we know, like in, let's say in terms of government, we know somebody selected as the central authority, and that central authority can regulate the country, can regulate the laws and give laws, and people have to obey and the rest. And that's how it works in the central authority, like in a centralized network. Now, when we're dealing with decentralized network, it automatically means there's no central, there's nobody like in charge. I'll be like, okay, fine, do this, do that, do that. So that's where consensus algorithm comes in place. There are protocols, right, that will facilitate agreement among nodes. That will be like, okay, in this particular network, what we're going to do and need is before a transaction is successful, you need to go through these certain protocols. So that's what consensus algorithm does in blockchain. It ensures that there's like a consistent state and consistent protocols that have to go through, that each transaction or whatever you want to do on the blockchain have to go through before that can be successful. So that's where consensus algorithm takes place. Now, there are different types of the consensus algorithm. Okay, but before then, let's look at the importance. One is it enables a trustless system without relying on a central authority, enhancing security and resilience. So by this algorithm now, we can actually build like a trustless system where it's not one person that is in charge. It's not like a central authority that is in charge. And it's the fact that once transactions are confirmed, they cannot be altered, proving a tamper-resistant ledger. No, yesterday we said blockchains are immutable, that is, they cannot be altered. So using this algorithm, it ensures that transactions cannot be altered once those transactions are confirmed. And then we have the finality, where it ensures finality, confirming the validity of transactions and preventing double spending. So before a transaction can take place, the validity of that transaction has to be confirmed. That's what this consensus algorithm does, and that's its use. It makes sure that every transaction is valid, and it makes sure that it ensures that transactions, once confirmed, they cannot be altered. And then it enables a trustless system without relying on the central authority. Now we're going to be looking at examples. We have proof of work, we have proof of stake. Proof of work is being used by Bitcoin in particular. Proof of stake is being used by Ethereum. Now, what are the differences? Proof of work requires participants known as miners, and each miner has to solve, like the first miner to solve a complex math problem to validate transactions. So this, like the use of the miners are that to solve mathematical problems in order to validate transactions and to create new blocks in the blockchain. Now, what this do, I'm sure we have heard of mining farms in blockchain where we see people with advanced machinery, computer machinery, and then they tell you this is a Bitcoin mining farm. So what they're doing is those machines are solving complex puzzles, right? And for the first person to complete the puzzle, what it does is you'll be given the chance to add the new block, and then also the transaction fees gets to go to the particular miner that solved the issue. So that's how transactions are validated using proof of work. Now, using proof of stake, these participants are known as validators. In proof of work, the participants are known as miners, but in proof of stake, they are known as validators. Now, how this works is they are chosen on the number of coins they hold and are willing to stake as collateral. That is, for each transaction that takes place, this proof of stake, what it does is that it selects validator. How is the validator selected? It depends on how much you have involved. So a validator that has higher money than you would have higher preference when being in order to be chosen to validate the transaction. Do you understand how proof of stake works? So, and then one thing about proof of stake is this, is that once there's like, in terms of security, once it's noticed that you are kind of fraudulent or something, there's a chance that you can lose the money you have staked before, that you have before in your, that you have staked before. So by this, it ensures that validators are, I don't want to use the word trustworthy, but it ensures that they take the right steps and do the right thing before they validate a transaction, because there's a stake of that money being confiscated or being lost. And yeah, so that's how proof of work and proof of stake works. And that's it for consensus algorithm. Please, do you have any question for now about these algorithms? Okay, moving on. That's consensus algorithms. Now we'll be looking at IPFS. IPFS is a distributed protocol designed to create a decentralized method of storing and sharing hypermedia in a peer-to-peer network. It uses a content address system to uniquely identify files. Now, IPFS is used to store files. It can be used to store media. Most decentralized applications makes use of IPFS to store their media, even to NFTs. Some NFTs are stored in using IPFS, yeah. So it's a distributed protocol and it uses a content address system. So we're going to understand what content addressing means. Now, IPFS uses cryptographic hash functions to address content by its unique hash rather by location. Now, what does this mean? It means that for IPFS, sorry, it uses cryptographic hash. Now we understand what cryptography means at this particular point, and then we understand that cryptography is used to secure communication. Now, for it to locate a particular file or content, what it does is it generates a what we call content identifier. And using that content identifier, it's going to use that to locate the file instead of using the traditional way of using location. They'll be like, okay, if you want to locate a file, you have to go through the location, the directory. Instead, it will use this particular unique hash, yeah, to find the file. Now, we also have peer-to-peer communication. This is like one of the core principles of IPFS. Now, peers in the network communicate directly, facilitating content distribution without a central server. So what this means is we said the file is stored, right, using a decentralized distributed system. Now, what it does is that whenever I'm looking for the file, the peers in the network will begin to communicate, asking who has the file, and that way it can actually get like the content distribution is facilitated without a central server. Then we also have versioning and the duplication, where IPFS manages versions of files and like that. Now, how does it work? We have the file addressing, right? Okay, so as we said, the file addressing, we said contents are addressed by the content. Files are addressed by the content. I mean, and meaning the unique hash of the content is used to locate and retrieve the file rather than relying on the specific server or location. Now, the use of content-based addressing to identify and retrieve files based on the unique content identifier. The content identifier is generated from the file itself. It takes a look at the values in the file and then it generates a content identifier. Now, using that content identifier, it can now be used to retrieve the file. Do we understand how it gets to retrieve the file? Now, second point is what it uses DHT, which is a distributed hash table, to store and retrieve content by mapping content identifier to network peers, right? So for this, what it does is, sorry, yes, sir. So what it does is it connects the content identifier, the CIDs. So whenever you hear me talk about say CID, just know is content identifier. So what it does is it connects it to network peers, that is to peers. So whenever the network requests for a particular file, it's already what it does is it points you to the network peers that has the particular files, and then from there, using the DHT, using the CID, you can now use it to locate where the file is. So that's how IPFS uses distributed hash table, and then files are shared and replicated across the network using IPFS nodes. We know what nodes are, and we know that so using those IPFS nodes, the file are shared and replicated. So do you have any question about how it works? Do we have any questions so far on how IPFS work? We need to understand this IPFS very well because it's something that, as a developer, you at some point you're going to make use of. So you need to understand the technology behind it, how it works. Right. All right. So
Hello.
that's just how it. I think somebody's trying to.
Irene. Hello,
Yeah,
Mr.
hello
Lee.
Daniel, you can unmute.
Okay. So I don't know if you can hear me. I want to ask a question about this IPFS.
Okay.
Yeah, because at some point I was like, I was asking a question actually on this, when like, each time we create wallet address, we have our seed phrase keys. So I was like looking for a secure place that someone can actually save data, can save his or her seed phrase keys, because at some point when you say,
Sorry,
let me
I
save it
can't
on
really
my,
hear you. Yeah.
can you hear?
So we can't really hear you. Yeah, it's better now.
Hello? Can you hear me now, sir?
Yeah, hello, we can hear you.
Okay, I said like I was looking for like a place someone can save his file, like seed phrase keys. Because when you say let me save it on email, sometimes you experience hack. Save write it on paper, sometimes you get your total loss. So I was like using IPFS to save those files. But I was like, how secured is it that nobody else can access it? Does it mean that nobody else can access it aside the person you give the public key?
No, no. So with IPFS, you're going to be given a URL, and one thing about that URL is it cannot be altered. One, but then anybody that has access to that URL can view the content of whatever is inside. So
Okay.
IPFS, I don't think it's recommended to store your private key or your phrase in particular, except you're going to, you still have to store it privately, which is the same thing as storing your phrase privately.
Okay. Okay, but I was like, since
Yeah.
nobody else can view it, aside someone that have your URL, which you can read in
So
directly
I didn't get
because
you.
now I'm like, since nobody else can view it, aside the person that have the URL.
Yeah, so if it's stolen from you, the person can actually view it too. So that also is almost like just your phrase. If it's stolen from you, it can be accessed.
Okay, thank you.
Yeah. You're welcome.
Yeah, so generally, it's not
Okay.
recommended to store
Okay.
any sensitive data on IPFS because anyone with the URL can access the data, and it's decentralized. So your data is replicated across different systems. That means you'll be able to delete it from all the nodes. So some nodes, after you delete some node, might still decide to keep those files forever or indefinitely.
Yeah, so I think that's even a better explanation. Okay then. We'll be looking at the components of IPFS. We have the IPFS node, we have the file system, and then we have the content routing. To understand IPFS node is an instance of a device or computer running the IPFS software. So I've been explaining what node means. So just know that it's like a device running the IPFS software. And so what it does is it participates in the network, the IPFS network. It enables it to store, retrieve, and then share content with other nodes in a peer-to-peer manner. So that's what IPFS node means. And okay, we need to also understand that each IPFS node has a unique identity, which is derived from its public key. The identity is used for secure communication, that is cryptography in particular. So how nodes communicate with each other is secured using cryptography. Each node has its own unique identity, and with that, it's derived from actually the public key, and that's what you need to understand about IPFS node. For the file system, it is a distributed and versioned file system that forms the basis of the IPFS protocol. Now, unlike traditional file system that organizes file based on their location, the traditional way of organizing files is based on location. That is using directory paths. If you want to save your images, you go to your images, so like that, like that, like that. But IPFS doesn't use that approach. What it does is it organizes files based on their content using the content addressed approach. So that's what we need to understand about file system and how IPFS handles organization of files. And yeah, we said files have unique content identifiers, which is generated from the file content. And then the CID, the content identifier, becomes the file's address on the IPFS network. So that CID is going to generate for you. That is going to be the file's address on the IPFS network. So that's what is going to be used. So you need to take note of that. Now we have content routing. It involves the mechanism used to find and retrieve content within the network. So once you hear content routing in IPFS, just know it's the mechanism behind finding and storing files on the network, within the network, yeah. And how does it do that? It makes use of DHT, which is the distributed hash table that we talked about previously. And how does DHT works? It maps content identifiers to the network peers so the network peers are responsible for hosting that particular content. So the network peers could be like a group of peers, yeah, which so whenever a node wants to retrieve a specific file, it queries the DHT, the distributed hash table, to find the relevant peers. So once you want to find your file that you uploaded, what it does is to query the DHT. The DHT will point to the network peers that are responsible for hosting your file or your content, and then from there it can be retrieved. And so it also helps in decentralized and efficient content discovery, and then allows nodes to navigate the IPFS network. So that's how the components of IPFS works, and these are like the key components. So I believe with this we have some knowledge on how IPFS work. Please, if you have any question, you can ask probably on the components or how it works. We can just quickly understand it. And then from here, we'll move on to a demo of how to work with it. Okay, please.
Yeah, Paul, you can unmute. You've been raising up your hand for a while.
All right, so my question is interacting with a decentralized social media network, social media application, and let's assume the application makes use of IPFS to store data. Um, how does IPFS like?
Sorry, we can't hear you.
Can you hear me?
Can't hear you.
Can you hear me now? Can you hear me now? Hello? Can you hear me?
Yes, it's
Yes,
better
it's
now. Yeah,
better
it's
now. Yeah,
better. We
it's
can
better.
hear
We
you.
can hear you.
Okay, all right. So I said that when I'm interacting with let's assume I'm interacting with a decentralized social media application, and the social media application makes use of IPFS to store users' media files. How does IPFS guarantee the speed? Because the application is already deployed to a network, and there has to be speed for people to have a better user experience. And using like IPFS also to store data, it's more like we are interacting with two different networks. So we are interacting with the IPFS node, and we are interacting with the social media application, what's it called, network.
Hello,
So
Paul.
can you hear me?
Sorry, I think my network is.
Can you hear me?
Yeah,
Yeah,
can I
can
take
I
that
take that
question?
question? Do you understand the question?
Yes,
Yes,
I get
I
you.
get you. Yes. Like every
So
network
so this
has
how
a
it
certain
works.
speed, has a certain speed. So what's the speed of IPFS like to guarantee fast, what's it called, sharing of files? And
Okay, so regarding that, you asked about the speed of IPFS and also um, if the speed is guaranteed, if I'm correct. But one thing you have to know about IPFS is that when you're coming from the traditional Web 2 um, development and ecosystem, you can just see IPFS as something like Amazon S3, where you can store data. You don't really need to worry about how the data is stored because that one is really low level, because all you care about is that when you upload something into S3 and you get a URL, you should be able to access that information via the URL. So that's the same way um, IPFS works. But this time around, instead of having it on a centralized server like AWS data center, it is stored on several computers all over the world. So it's not stored on a single server, or it's not decentralized. So you can be rest assured that your data is always available. So that's how IPFS works. And when it comes to the speed can vary depending on the service provider you are using, and also the maximum file size limit that you can upload to IPFS also depends on the service provider and a lot of other factors that comes to play when it comes to uploading, and also your current location. If you are located in maybe um, Nigeria now, then maybe the node you're accessing is somewhere very, very far away, then you should expect that the speed will be a bit slower. So that's how it works, basically. So it's just like the traditional way of accessing data, but this time around, instead of using a centralized server, you're using a decentralized system. Hope I've been able to answer your question properly.
okay, yes. So we won't go to the low level complexities of it. Thank you.
So I didn't get that question. Please, if you can just drop the question in the message box so that we can address that while we move on to the next thing. Yeah, King, over to you. Thank you.
All right. Thank you very much for the answer. Okay, we are supposed to move on to a demo of how IPFS work. But currently, those of us physically, we have like a technical issue with our screen sharing. So I would just like us to take 3 minutes break, and then we'll be back by 11:30. Thank you. Okay, so we're back. We'll be rounding up from here. So the last thing we're going to be doing is we're going to see an example of IPFS, how it works, and we're going to make use of the last URL in the Notion resources. So this nft.storage/docs. Please let's instead of using this. Please use the link I sent via the chat. And then I just sent it on WhatsApp. So please let's make use of those links. Okay, so this is NFT storage. Is a storage free storage for NFTs. So let's signify if we have gotten access to it. All right. So on the top right, you're going to see the login button. So I think because I'm logged in already. So you can click on the login on the navigation bar, and then you can proceed to create an account. I'm just going to make it. If you have a GitHub account, you can make use of. You can connect it to your GitHub, or you can make use of your email. So I'll just go ahead to connect this to my GitHub. And wait for it to load up. Now, so to take you to the dashboard, you can upload and you can view your previously uploaded files. I think myself I've uploaded one, or this was this morning. So you can just go ahead to upload, and then you can choose a file from your local directory, and I'll just click on this, and then I can decide to upload it. So you can even see from the note down, you can see that you are not to store any private or sensitive information in an encrypted manner. I'll notice from the table, when you are uploading, you notice that you see CID, which is the content identifier for the file. And then you see the providers. And then under action, you can see view URL or copy IPFS URL, and then copy CID in case you want to make use of the CID. And like that. So from here, you can access, you can just click on them to understand how. So notice that when I clicked on view URL, it downloaded the file that I uploaded. So you can see that it's downloading the zip file on my personal laptop. So with this URL, you can access it. If you want to download it, you can download it. You can decide to copy the URL, and you can decide to make use of the URL. You can also decide to copy the CID, because there are certain people that want to make use of the CID in their application. So this is how IPFS storage works. There are different providers. This is just one of them. So you can research, find more about them, make use of the one that is suitable for you at that particular point. But basically, this is just an example of how IPFS upload and accessing, retrieving such files works. So that's what you need to understand. All right, so we can just take the next 2 to 3 minutes or even 5 minutes to play around with it, and then if you have any question, you can now drop it into the chat box. So please so from now till 11:48, please let's just play around with it. And in case you have any obstacle or issues, please drop it in the chat box and then we'll respond to it. So just play around with it and then ask any question that arises from it. Thank you.
Hello, everyone. So, if you have not followed us on social media, please follow us on all social media platforms and also interact and engage with our posts. Thank you. I'll drop a link so it's easier for you to follow from there.
Please, Tosin, you can provide a screenshot on WhatsApp, and then assistance can be rendered to you from there. All right. So this is 11:47. We still have 1 more minute. Okay, 11:48. Okay, good. So that was going to be all for today. So far we talked about cryptography, the types of cryptography. We also learned about we learned MetaMask, how to get faucets from Arbitrum, Sepolia to our MetaMask wallet, and then we also learned about consensus algorithm, and then we learned about IPFS. So okay, please, for those of us having issues with logging in to the NFT storage, please, um, you can send that to the WhatsApp group, and then from there, all will be rendered. All right. So that was going to be all for today. And let's remember that we have an assignment to do. The assignment can be found in the training 2 year curriculum. You have the cryptography and consensus algorithm. So in the assignment, we have investigate common security vulnerabilities in blockchain systems and propose strategies to mitigate them. That is, what security issues do you believe that exist in blockchain systems? And then you can propose solutions in order to fix those security issues. Please, let's make use of the same method we used for yesterday's assignment, which is using Ashnode or Medium. I believe we can make use of that also for this assignment. So you can just write it down, and from there you can submit it. The deadline will be passed to us on WhatsApp, yeah, by our moderator. So that was the assignment, and that was all. So thank you. See you tomorrow.
So thank you very much, King, for the wonderful session. But before we call it a day, we should ensure that we are not using AI to do the assignment, because we are checking. And if you check the board, you can see comments on the number of percentage of AI detected in your work. So for some people it's 100%, for some people it's 98, 49, 45, depending. So please ensure that you do not use AI. Then also you can see your grade beside each assignment that you are submitting. Then also, whenever you are submitting, instead of um, using the what's it called the instead of putting the title as maybe benefit of blockchain, just put the training number. If it's training one, just write training one. Then your name, then the live demo or the repo, depending. So that's all you need to do. You don't need to write the topic. I can see some people writing topics, stuff like that, but you don't need it. Just specify the training number, if it is training 2, training 3, or training 4. And one thing about Notion is that for every assignment that you are submitting, we can easily track it just by filtering your name. So all the assignments you've been submitting from day one can easily be viewed from the dashboard. So thank you very much, and I will be looking forward to your submission today. Yeah, Esther, you can unmute. If you have a question.
Sorry, please, I
Esther, you
have a
can unmute.
question. Okay,
Okay.
thank you. Good morning,
I'm listening.
lecture. I have
Yeah,
a
good morning.
question. Pertaining to today's assignment, asking about how to mitigate security challenges. So I want to ask, will it be in text form, like how we are going to be doing, like how we did yesterday assignment? Is that how it will be? And the method of submission, I tried to look at yesterday video and understand how the method of submission would be, but I couldn't. Please, can you give a better understanding, better explanation on how the assignment will be submitted? Section board. Thank you.
Okay, so you can check the Notion board and you will see the assignment page. Once you click on the assignment page, you will see some assignment that have been done already. So just follow the same template and you submit. Then for the yesterday's assignment, we used Notion. Sorry, we used Medium. Some people use Medium. Some people used um, Hash node. So you are free to choose whichever um, tool is convenient for you. You can even use WordPress. If you have a personal website that you can post your article on, just post it and share the link on the Notion, but just make sure that it is publicly accessible. And also, someone asked that when is the submission deadline? One thing is that the submission deadline is weekly basis. So, for this week's project, you can, if you don't have time today to do it, you can do everything tomorrow. But you have to submit all your assignment by Friday or Saturday, depending on the last day of the week. So, if the last day of the week is Thursday, then we are expecting you to submit by 12 p.m. Oh, sorry, by 11:59 p.m. on Friday. And if the last day is Friday, then we are expecting to submit all the week's assignment by Saturday, 11:59 p.m. So that's what we mean by end of the week yesterday. So if you have any other question, okay, don't forget to share your social media. Oh, sorry, this one, Shulua. Okay, please. Okay. Yeah, that's all for now. Esther, I hope I was able to answer your question correctly.
Yes, thank you very much, sir.
Yeah, no problem. You're welcome. That question before we call it a day. We still have 6 more minutes on the call.
Also, let's not forget to share on social media what we learned in class today and also include the hashtag BIHX Arbitrum Bootcamp in all social media posts. Thank you.
Oh, sorry, I would also like to know how the attendance, because I was here like earlier on, but I had network issues.
Hello, sorry, I didn't get that.
Sorry, can you hear me?
Yeah, I can hear you now.
Yeah, I said I would like to know how the attendance is taking because I was here earlier on, but then my network was like fluctuating, so I joined again late. I don't know if I missed it.
Okay, one thing about the attendance is that we are not going to disclose how we are taking the attendance. So it's random. So don't worry. So far you join the class and you stayed for enough time, then you will be uh, graded
Okay,
accordingly. Don't worry. Yeah, thank you.
all right.
Yeah, Esther, you still have a question. You can unmute.
Yeah, sorry, I have a question. Based on today's class and what we did earlier today, about getting a passkey. So presently now I've downloaded the Brave web browser and I've added the extension MetaMask. So I'm trying to add a network manually as we did yesterday using Arbitrum Sepolia. But I'm getting an error here using the chain IDs telling me couldn't fetch chain ID. Is your RPC URL correct? So I don't know how I can go about it, but I'm trying to save it and it's not going through because of that error.
Okay, so you can send a screenshot on WhatsApp of that error. Then one thing I'm suspecting is there's probably a space before your URL. Maybe you can remove the space before and after. So that should solve that problem. But if there's no space before and after your RPC and your chain ID, then you can send a screenshot on WhatsApp so we can look into it and solve that problem. Then also there's a tool you can use to automatically add different network to your um, MetaMask, so you don't need to worry about doing that manually. So just go to chainlist.org. I'm going to provide the URL now. It's not part of the resources, but I can drop it here, chainlist.org. And once you go to chainlist.org, these are one of the benefits of attending a live class. You get to ask questions and get response in real time. So chainlist.org. So when you go to chainlist.org, you see list of networks that you can add. Let me see whether I can share my screen, and so you can come here, share, allow to share screen. Okay. Can you guys see my screen? Hello? Okay, so now just come here and search for Arbitrum. So once you search for Arbitrum, you can see that you can see Arbitrum 1, but there's nothing like Sepolia. There is Nova, there is XDAI. But when you click on include testnets, you see you have more networks, and you can just click on this one, connect wallet, and it automatically add Arbitrum Sepolia for you. Based on all these credentials, you can see the chain ID, you can see the RPC URL, you can see every other information about the chain. So that's all for now. So we have to end this call now because it's 12 already. Every other question will be answered on the group. And Ajibola, you asked when will the recording be released on YouTube? It takes like up to 4 hours for Google to process the video and send it to us. So once the processing is done, you should expect the Google Drive, and also we are going to post it on the on our YouTube channel. So thank you very much. Bye bye. Enjoy the rest of the day.